Hi, I'm Severin from the Technical University of Munich, and I'm excited to be presenting our work on the ethics of facial analysis AI. This work is a collaboration with Chiara Ullstein and Grossklags, both at the Technical University of Munich, and Orestis Papakyriakopoulos of Princeton University. In this research, we study how non-experts ethically evaluate facial analysis AI. Now please take a look at this portrait. What do you see? What impressions do you form in this process? In the past decade, we have seen the emergence of a visual data culture, and with it the development of computer vision AI that makes sense of visual data, and in particular our faces. For example, computer vision AI companies have developed data sets and models to predict concepts such as gender, friendliness, or intelligence from single portraits and videos. More than 2 billion images are uploaded every single day only across the Facebook services. So an entire industry has formed that develops AI tools to interpret semantically ambiguous visual data. Again, human faces in particular. Another well-known example is emotion recognition AI. Based on the view that emotion expression means emotion sensation, emotion recognition tools infer emotional states based on a taxonomy of facial action units. Emotion recognition applications have been used in advertising, automated hiring procedures, and surveillance of students during classworks and exams. Likewise, computer vision AI research has claimed to successfully infer personality profiles, political orientation, as well as a variety of latent traits such as intelligence or trustworthiness from human faces. In our fact paper, we offer an in-depth discussion of these different facial analysis projects. Importantly, there is a large corpus of research in psychology and evolutionary anthropology that has demonstrated that faces exert a near irresistible influence on us. So when we see a person for the first time, we cannot help but form an impression of that person. And we can clearly see that this irresistible force of faces has hit computer vision AI with a plethora of AI development, not just in facial AI analysis, but in facial detection, facial identification, and facial recognition as well. A recent review by Scheuermann et al. On 500 prominent computer vision datasets found that the majority of them were face-based. No other object was represented more often in computer vision datasets than human faces. Now, these developments have raised ethical concerns among critical data scientists. And they argue that facial analysis AI is an automated version of physiognomy, the pseudosciences of inferring character traits from facial appearance. Now, taking all of this together, we wanted to understand what non-experts in AI think AI should infer from faces. Given the semantic ambiguity of visual data, fixing the large space of interpretive possibilities to a selection of target variables is an act of classification. And this act of classification necessarily demands an ethical justification. So we believe that this discussion must take note of non-experts' ethical evaluations, and that these ethical evaluations must at least be complement to conceptual critical analyses. Consequently, our study creates an understanding of how non-experts justify what they believe differentiates ethically permissible from ethically impermissible facial inferences. To do this, we designed an experimental vignette study that asked 3,745 non-experts to ethically evaluate 8 facial AI inferences across 2 hypothetical decision contexts: a low-stake product advertising context and a high-stake hiring context. Participants rated each of the 8 inferences on a Likert scale and were then asked to provide a written justification for each of their ratings. We conducted the study with Amazon Turkers for a number of reasons. One key reason was that we wanted to understand how a group of people that have carried out much of the laboring work of computer vision datasets ethically evaluates specific AI facial inferences. Now, my co-author Chiara will take the lead and guide you through the methodology and result sections.
The experiment was a between-subject design with 24 groups. First, subjects were randomly assigned to one of 2 hypothetical contexts, either a low-stake advertisement or a high-stake hiring scenario. Participants were told that a company deployed computer vision AI to make a variety of judgments about either social media users or applicants based on their portrait. Participants were then told that these inferences, together with other assessment metrics, were used to show social media users more suitable product advertisements or to determine whether a candidate is suitable for a job. These scenarios fulfilled one of our study's aim to understand whether non-experts evaluate the same set of AI inferences differently across low-stake and high-stake contexts. Participants were then asked to rate each inference. After rating their agreement with the inference, we then asked them to justify their rating with a brief written response. Participants repeated this rating justification procedure for each of the 8 inferences. With 2 other experimental treatment groups, we accounted for framing effects. Please look at our paper for an overview of all treatments. Now, how does the analysis of the obtained inference ratings and the respective justification look like? To analyze the ratings, we first computed Welch t-tests to identify group differences on an aggregate level. Then, we used exploratory factor analysis to explore constructs underlying our set of 8 inferences. To analyze the written justifications, we derived a coding scheme by manually coding parts of the written justifications. This process consisted of 2 iterative cycles and was performed by 2 researchers. Based on the developed coding scheme, we used the language model Roberta to analyze the remaining comments. We then applied analysis of variance to identify group differences and further analyzed the differences in justification types. Now let's turn to the results. The exploratory factor analysis resulted in 2 constructs underlying the set of 8 inferences. One factor, which we termed first-order inferences, included the inferences emotion expression, gender, wearing glasses, and skin color. The other factor, which we termed second-order inferences, included the latent trait assertive, likable, intelligent, and trustworthy. We used these terms, first order and second order, as linguistic categories to reflect the statistical reality of subjects' rating. Plots from the 2-sample Welch t-test help us visually grasp the results. In the graph, the higher the bar, the more people found the inferences impermissible. First, we can see the difference in ratings on first and second order inferences. For instance, second order inferences such as trustworthy or likable are on average more frequently rejected than first order inferences such as gender and glasses. Second, we can observe the effect of the context shown to the participants for first order ratings. For example, people were more likely to accept the inferences gender and skin color in the advertisement than in the hiring context. No other experimental treatment had an effect. This indicated that the subjects in our sample had a robust concept of a normative facial AI inference. Now, let's have a closer look at how participants justified their ratings. First, we found that subjects evaluate the normativity of an AI inference according to 2 meta-principles, pragmatism and evidentialism. Pragmatic justifications reflect the relevance of the inference for the outcome. The justification type inference creates harm refer to, for example, discrimination due to racism or sexism. Another justification described comments stating that AI inference making includes human biases. Epistemic or evidentialist justifications considered whether an inference was proportional to the evidence. We identified two categories, AI can tell and AI cannot tell. With regards to second-order inferences, we found that subjects believe these inferences are invalid, meaning that faces do not provide sufficient evidence, regardless of the decision-making context. An exemplary comment states, if you're just looking at a person trying to determine if they're assertive, you're going to score no better than a random guess. The agreement by a small minority is justified with reference to relevance and AI's ability to infer. Moving to first-order inferences, subject justification profiles were more complex. The majority of subjects believed first-order inferences were epistemically valid, meaning that AI can make the inferences in both contexts. However, some raised concerns in their written responses even when agreeing with these inferences. For instance, one participant wrote, "Skin color is something that can be visually seen, but there is lots of room for error." In the hiring context, considerations of relevance became more important reasons to reject an inference in comparison to the advertising context. Here, subjects believe that both skin color and gender are relevant AI inferences in advertising. Finally, we would like to highlight that we encounter justifications such as this one. A person's emotion can be seen pretty well by looking at the picture, as I have done surveys in the past deciding emotion through facial expression. Here, we clearly see that we have entered a repetitive cycle. Companies ask labelers to make specific inferences, and labelers then learn or accept that these inferences are valid. Now, my co-author Severin will present to you a summary of our findings.
Alright, so we find that subjects believe AI should not draw inferences such as intelligence or assertiveness because of their epistemic invalidity. Overall, our analysis highlights the normative complexity behind facial AI inferences. Subjects raise concerns about all AI inferences, and in particular about the sensitive inferences gender and skin color. Here, the decision context influenced subjects' evaluations. A majority of the non-experts in our sample believe that facial expressions are reliable indicators of emotion. Nonetheless, their justifications reveal that many of them think that emotion as social signaling can be different from the internal phenomenological experience. We find that non-experts are either evidentialists or pragmatists. They assess the ethical status of a facial AI inference based on whether they think faces warrant sufficient evidence for an inference or whether making the inference results in a relevant outcome. Finally, we want to briefly discuss the implications of this finding. Again, we find that some subjects use a pragmatic rationalization of epistemically questionable AI facial inferences when they believe that an AI inference is relevant for a decision's outcome. However, why should the normativity of a vision-based inference be evaluated by criteria other than evidence? The decision context does not have any bearing on the relationship between evidence and inference, and therefore should not lead to a different normative evaluation. But as we show, visual data inferences may often be rationalized by such pragmatic considerations. Taken together, over-reliance on AI capabilities, narratives of bias-free technological decision-making, and beliefs in the relevance of an inference for the decision context may form a line of reasoning that supports justification of epistemically invalid AI inference making. Thank you very much.